Welcome to lesson 19, where we're going to study ions. That is the big idea here. So we've gone and we've looked at core electrons, valence electrons. Now we're going to study what happens with those valence electrons, okay? So some atoms will gain or lose electrons when they interact with each other. Atoms that have lost or gained electrons are called ions, okay? When an electron is gained or lost, the resulting atom has some form of a charge on it. So a charge would be something that is positive or negative, okay? That is something we're going to learn about in this lesson. Ions tend to have an electron arrangement that is identical to that of a noble gas. So something to think about, we learned about nuclear reactions, and that is where the nucleus of an atom will change. So the number of protons or neutrons will change. Well, here we're dealing with changing the numbers of electrons, okay? So we're not messing around with the protons or neutrons, we're just changing the number of electrons. So the identity of the element or the atom is not going to change here, but it's going to look like something else. It's going to want to behave like something else. And here we're going to want to look or behave like noble gases. Okay, so what is a noble gas? Let's think about these before we get anywhere. A noble gas, we find those in group 18 or 8A of your periodic table. We have helium, neon, argon, krypton, and xenon. Okay, another one you have is also radon, but this is the best picture I found online. Noble gases are not reactive. They have a valence electron structure that is full. Okay, in the last lesson, you learned that valence electrons are really important. Okay. And so the outermost shell is called our valence shell. And when we have those valence shells, we want them to have two, for example, with helium, or 8 valence electrons to be considered neutral, okay, or full. Those outermost shells are full. If the outermost shells of atoms are full, then they're not going to form any more compounds or need anything else to become, electronegatively stable, okay? All right, so the learning goals here we're going to be able to explain that an ion is formed when an atom loses or gains electrons, and be able to state the difference between what is, a cation and what is an anion. You're going to be able to determine the charge on an ion based on an atom's placement on the periodic table, okay? You're going to explain the relationship between ion charges and valence electrons. So 3 vocabulary terms we have here. One is an ion. So again, this is the main idea. It's an atom or a group of atoms that have a positive or negative charge. This is where we gain or lose electrons, okay? There are 2 types of ions. We have cations and anions. So a cation is one that has a net positive charge. We usually see these as metal atoms. And this is where we have lost electrons. Electrons are negative, so we're getting rid of negative charges. A lot of times I like to tell my students, think of yourself as a cation if you are getting rid of bad friends, okay, or bad influences in your life. You are becoming more positive, so you would be a cation, okay? An anion is an ion with a net negative charge, okay? So this is usually our non-metal atoms. Remember, we find those more on the right-hand side of the periodic table, okay? And here we have gained electrons. So we're becoming more negative. You are an anion if you are gaining bad friends or, bad acquaintances, ones that are getting you in more trouble, okay? Something also to think about, the word part a or an that you see here as a prefix, that just means not or without, okay? So we're getting more negative, okay? You're probably thinking, why do you have a picture of a cat on here, and why is this listed as Good Cat Chelsea? My high school chemistry teacher, Mr. Bob Sakona, he still teaches, he had a cat named Chelsea, and the way he got us to remember the difference between cations and anions was, he said, my cat Chelsea is good, so he would refer to her as Good Cat Chelsea, okay? Well, why Good Cat Chelsea? Well, if something is good, we think of it as positive, and that cat would be like a cation. So we are becoming more positive. So cations will have positive charges, or we can think of them as good. Anions have negative charges, or we can think of them as bad. Okay, let's prime the pump here. Chemists have found that the metal atoms transfer electrons to non-metal atoms when they form compounds, okay? So examine these two shell models that we have here, lithium and fluorine, okay? This is going to kind of try to show us why lithium, or the metal, will transfer an electron to a non-metal, okay? What effect does this electron transfer have on each charge of the atom? Okay, so lithium has one electron out there, and we're transferring it over to fluorine. So if we're getting rid of an electron, we're becoming more positive because we're getting rid of that negative charge. So if we're getting rid of the negative charge, that means that lithium will have a positive charge, or a +1 charge, okay? What element does each... Oh, sorry. I have to talk about fluorine, I guess, before I answer the next question. Fluorine is gaining an electron, so it's going to become more negative. You want to tell yourself, more negative by what? Well, we're gaining just one electron, so we're becoming more negative by 1. Okay? Question number 2, what element does each atom resemble after the electron has been transferred? Well, you want to look at your valence and your core electrons. You can utilize that sheet. Since lithium is getting rid of one electron, it will only have 2 electrons, so it's going to resemble helium. Find helium on your core and valence electron sheet, okay? It has 2 valence electrons, okay? And then fluorine will now resemble neon because it has 2 total shells, and its outermost shell is full with 8 valence electrons, okay? So again, this is just representing, a neutral atom, a negatively charged atom, and a negatively charged atom is where we have more electrons than protons, because we think about those charges, they can't balance each other out. And if an atom is positively charged, there are more protons than we have electrons. The table of arranged ion cards for this activity shows that the charges on the ions are quite predictable. Ions in the same column will have the same charge. Take a look at this picture below, okay? Positive charges will be found on the left-hand side of the periodic table, negative charges towards the right, okay? We want to think, what is the easiest way to become stable? Do I want to gain electrons to become stable? Do I want to lose electrons to become stable, okay? Typically on that left-hand side of that periodic table where you see those positive charges, we are losing electrons. Again, think of it as a board game. Is it easier to gain 7 electrons if you're in group 1, or is it easier to just get rid of 1? Okay. When electrons are removed or added to an atom, the rest of the atom stays the same. So electrons just show charges of the atoms. Since we're not changing the actual numbers of the protons here, we're still going to have the same element. Okay. So the identity only changes when we change the number of protons. And from section 3, where we talked about isotopes in lessons 13 and 14, isotopes only change the number of neutrons, okay? And the atom and the number of protons stays the same as well, okay? So here you have 2 different hydrogen ions. We have one with 1 electron and one where we give up an electron, okay? The charge on an ion is noted with a superscript. So we've talked about subscripts telling us how many atoms of each element we have, but here we're going to have superscripts. So for example, these superscripts are going to be positive or negative, okay? Positively charged ions are called cations. They've lost their electrons. Negatively charged ions are called anions. They have gained electrons. For example, if 1 electron is removed from lithium, that lithium ion is written as Li with a +1 charge, okay? Li with a +1 charge, so that's going to be Li plus, okay? Removing 3 electrons from aluminum results in aluminum with a +3 charge, okay? You can list the positive sign first, or you can list it second. A lot of times you'll see it listed second. The majority of the time, sorry, you will see it listed second. But for right now, since we're just learning about it, if you want to put +3, that's fine. If 1 electron is added to chlorine, we're adding an electron. That means chlorine becomes more negative. Okay, so it's written as Cl with a -1 charge. If we have oxygen, oxygen has 6 valence electrons. So to become more stable, we need to gain 2 more electrons. So it'd be oxygen with a -2 charge. Okay. Ions formed from transition elements are exceptions to those simple rules that we just talked about. The charges on those transition elements are not as predictable as those in the main group elements. Later on in this section, we'll address those. So we have to really identify what these elements are gaining or losing to figure out what their electron charges are here. So after an electron transfer occurs, the electron arrangement of the resulting ions will look really similar to those of noble gases, okay? So they're going to gain or lose electrons to look like their nearest noble gas. Again, that's why we want to think of the periodic table as a board game, okay? For example, if we have sodium giving up an electron to chlorine, you will see that sodium no longer has that 1 valence electron. That sodium will then look like an atom of neon, okay, because we have those 10 total electrons like neon has with an outer shell that is full. Chlorine is going to gain an electron. So what is closer to chlorine in terms of a noble gas? You're going to have argon. So chlorine is going to resemble argon here. They're not becoming those noble gases. They're just going to look like them. Okay, atoms tend to gain or lose electrons to attain the electron arrangement of a noble gas. Atoms want to become stable or they want to fill their outer shells. Okay, this is why this is called noble gas envy. Okay, this is something that we can say, hey, this is really powerful in helping us predict the charges on ions. Okay, noble gases have chemical stability. Okay. It appears that atoms will combine with each other to form compounds only if the result is something fairly stable. Okay. So take a look here. This is kind of what your cards would look like, missing a few things such as the name. But you will notice everything in group 1A has a +1 charge. Everything in group 2A has a +2 charge. Everything in group 3A, or we can say this is group 13, has a +3 charge. 4A, we can gain or lose electrons. Most of the time, you're going to see it would have a +4 charge. In group 15 or 5A, we'll have a -3 charge. Group 16 or 6A, a -2 charge. Group 7A or 17, a -1 charge. And you will notice everything in group A, 8A, or group 18 has a has no charge. Okay. So again, if you take a look, we have lithium and fluorine forming a compound together. Well, lithium has 1 valence electron, so they want to get rid of it. What happens if lithium gets rid of its 1 valence electron? It will look like helium. So put your finger on lithium on your periodic table and move back 1 space. That's what it's going to look like. It's not becoming helium. It's going to look like helium. Okay. Fluorine, put your finger on fluorine on your periodic table. It's atomic number 9. If it gains that 1 electron from lithium, we're going to bump forward 1 space, and this is then going to resemble a neon atom.